This video is a review of beta oxidation. Beta oxidation is the oxidation of a long fatty acid chain. Beta technically means the second carbon, and then oxidation is the loss of an electron. So beta oxidation is going to strip off 2 carbons at a time and get energy out of them. That's the process of beta oxidation. So we start our story with a fatty acid. These are long hydrocarbon chains, just a shortened version drawn up here in the corner. The first thing that we have to do to this fatty acid is we do have to activate the fatty acid and form acetyl-CoA. To activate the fatty acid, it's going to require energy, so we will use an ATP molecule to activate that fatty acid to make it ready for beta oxidation. So acetyl-CoA is an activated fatty acid. Now, for our purposes, we're not going to dive into the steps of beta oxidation, but we will look at what we get out of it. One round of beta oxidation ultimately produces another acetyl-CoA, or maybe the term another isn't correct. It takes the original acetyl-CoA and you still are left with it. It's just short by 2 carbons, N-2. So it's as if after beta oxidation, we still have the hydrocarbon chain, just short this one little chunk of carbons. So beta oxidation will just shorten your fatty acid chain by 2 carbons. In the steps of beta oxidation, we do get energy out of this molecule to be used by other pathways. So during beta oxidation, we're going to take an FAD and load it up with hydrogen, carrying those necessary electrons. There will be a step that takes an NAD and loads it up with the hydrogen to carry electrons. Now that we've loaded up NAD and FAD with electrons, they can float on over and enter the electron transport chain, which will ultimately get the ATP out. Since acetyl-CoA is short by 2 carbons, we also have a step where we're going to strip off an acetyl-CoA. That is that same 2-carbon molecule that we talked about in glucose metabolism that will ultimately be able to enter the TCA cycle, where it can strip more electrons off that can be used to generate ATP. So what you'll notice is that beta oxidation has created high energy electron carriers. It's produced an acetyl-CoA, which can be further oxidized in the TCA cycle. Beta oxidation itself did not generate any ATP. It also didn't use any oxygen directly. But beta oxidation is considered an aerobic reaction because if there is insufficient oxygen at the electron transport chain, then there's nowhere for these electron carriers to get rid of those hydrogen molecules. And ultimately, we'll fill up our FAD and NAD, and we won't have available electron acceptors to keep stripping electrons off of any more fatty acids. The failure of oxygen to accept the final electron in the electron transport chain will actually stop beta oxidation because we will have insufficient electron carriers to take the electrons and we'll be unable to oxidize that fat. So beta oxidation doesn't use oxygen directly, but it's considered aerobic because if there is insufficient oxygen, we have no way of keeping beta oxidation going because we won't have enough carriers for the oxidation to occur.